Hello everyone, welcome to Simon's Tutoring. Today I will introduce the derivative in calculus. What is calculus? I define calculus as a mathematical language express a change. What are the other mathematical languages? Before starting calculus, I will quickly explain the difference between English and mathematical language. English describes this situation in our lives. I have 5 apples, add 2 more. Gravity is the pull an object down. However, we can translate this language into mathematical language. But math language defines precise relationships like this. 5 plus 2 is 7, or F equals G times M1, M2 over R square. If you know how to translate English into mathematical language, math will be more attractive and you can see calculus from a different perspective. So now let's see what the calculus is. Calculus is the language of change. Therefore, we need to see what kind of change we have in our daily lives. Also, how is it defined in math? Let's see. The old car moves slowly. However, the sports car moves very fast. Stock market or economic increases or decreases. The population can grow or decay with time. These are all describing the change in our daily lives. However, all of these changes are defined as a slope in math. What is a slope, and how is the slope defined? Slope represents the relationship between rise over run on the graph. Rise over run means the vertical distance over the horizontal distance, or the vertical difference over the horizontal difference. This is a slope. Yes, the steepness is the slope. Another familiar thing related to slope is speed in our daily lives. A man is running. When a man runs, his speed is 0.5. An old car has a speed of 1, and a fast car has a speed of 2. We can say that the speed increases and the steepness also increases on the graph. Therefore, we can say that speed is slope. The speed increases, the slope also increases. In math, we use symbols instead of letters, so we use delta y and delta x to express the slope. Therefore, delta y over delta x is the mathematical language to express the slope, which is called the average rate of change. Delta y represents the vertical difference, and delta x expresses the horizontal difference. Graphically, we can express this as delta y and delta x. The slope of a line describes consistent speed or rate of change throughout the interval. Someone is consistently running the same distance in the same time. This is called consistent speed, or the same rate of change, since the difference in distance over time is the same throughout the whole interval. However, the curve slope is inconsistent, which changes the slope or rate of change over a given interval. If a man is running at a different speed, his speed will change differently over time. Yes, at first he's a little bit slow, but he's getting faster. His speed increases in a certain time interval, which can be described as a curve in the graph. This is called a non-constant speed, or slope change over time. Therefore, we can say the slope's nature can be consistent or inconsistent depending on the situation. How can we measure the non-consistent slope? There are 2 methods. One is the average rate of change, and another is the instantaneous rate of change. The average rate of change can be measured by the secant line. The secant line passes through 2 points in a given interval. After connecting the 2 points on the curve, we can measure the slope. This average rate of change shows the slope of the curve, but they have different meanings. Why is the instantaneous rate of change important to us? Look at these 2 curves which have the same average rate of change. However, the slope at the endpoint, such as the tangent line slope, is quite different. This comparison shows the average rate of change is not enough to describe the change at a moment. So, to overcome this limitation and achieve precise prediction or estimation at a given point, we need to calculate the instantaneous rate of change. This is a big question in calculus. How can you find this instantaneous rate of change? How can you find the slope of this tangent line from only one point? Look at this graph. When the 2 slopes are the same, the delta y and delta x get smaller and smaller. The secant line slope approaches the tangent line. However, we can see that delta y and delta x are close to 0. Therefore, we have a big problem finding the slope at a single point, because the same point and coordinate can have different meanings. For fa minus fa over a, and a will be a 0 over 0 form. This is called an indeterminate form in math. This indeterminate form does not yield a definite value. It means we can't calculate. We have a problem. We can't find the instantaneous rate of change at one point. How can we overcome this problem and find the slope at a single point? Mathematicians employ a powerful concept called a limit to avoid the indeterminate form 0 over 0. Limit means approaches. When you see that the secant line slope is close to the tangent line, such as b1, b2, b3, b4, etc., it is close to the tangent line. The x-coordinate b is close to a. It means that when the secant line slope is close to the tangent line, b is close to a. We can express this situation simply using a limit, since b approaches a and fb is close to fa. This can be expressed as the following symbols with a limit. Look, if we use the definition of limit, which is a value of approach to another, it shows that the average rate of change is close to the instantaneous rate of change. Therefore, we can say the combination of the average rate of change and the limit can create the instantaneous rate of change. Therefore, we can derive the formula of the instantaneous rate of change at a single point, and we can calculate the slope of the tangent line to a curve. Using this example, let's find the tangent line slope at fx is x squared at x equals 1. At this point, we want to find the slope of the tangent line. The formula for the slope of the tangent line is limit x approaches a, fx minus fa over x minus a. When you see this formula, it is composed of two parts. The average rate of change is combined with the limit. Let's summarize the given information. That fx is x squared and x is close to a. Here, a is the same as 1, since x approaches 1, and fa is also 1, since 1 squared is 1. Let's plug all of this information into the formula. Here we have the result x squared minus 1 over x minus 1. We can avoid indeterminate forms since we have the limit in this equation. As mentioned previously, a limit is the approach to the values, so x is exactly the same as 1. Therefore, we can factor out and safely cancel the common factors. Finally, we have a value of 2. It means the tangent line slope at the point x equals 1 is 2. This is called the instantaneous rate of change at x equals 1. Therefore, we can find the slope at one point using the formula that combines the limit and the average rate of change. This mathematical process of finding the slope at a single point by combining the limit and the average rate of change is called the derivative. In summary, derivatives are the mathematical process of finding a slope, a tangent line, or an instantaneous rate of change using a limit. When we combine the average rate of change and the limit, we can find derivative formulas. Visually, we can show this like this. This is a secant line close to the tangent line with x close to a. This visual idea can be expressed in this formula. If you find this video helpful, please subscribe to my channel. I also wrote a crash course book for students beginning calculus. This book is Calculus Made Easy. You can order on Amazon.